Question number 16, part 2. Ground state term symbol for metal ion present in cobalt, that is coenzyme vitamin B12 is, you see, the metal ion present in coenzyme vitamin B12 is cobalt. That cobalt exists in +3 oxidation state. This cobalt ion exists in +3 oxidation state. You have to know this. So for CO3 plus, it's a D6. It's a D6 metal ion having the configuration. It has 4 unpaired electron. So now for d orbital, you know L equal to 2. Now for S, the spin is, there are 4 unpaired electrons, so off plus off plus off plus off equal to 2. So S is equal to 2 and L equal to 2. And you calculate the multiplicity 2s plus 1, that is 5. Now you calculate the ground state term symbol, which is J. In denominator it is L plus S, and numerator it is 2s plus 1, that is multiplicity, which is 5 D 2 plus 2 4. So the final answer is D 5 4. So option B is correct. Here you see this S1 is ruled out, and these are all ruled out. Next, question number 17. The function of hemoglobin is 2. So simple question. Now you see here, it does not store oxygen in muscle unit. Option A was ruled out. It does not catalyze any biochemical process, and it help in muscular movement. No. Now it transport oxygen from lungs to various tissues through blood. The main function of hemoglobin is to transfer oxygen. It's a oxygen transport. Okay, option C was correct. Next question. Calculate the absorbance A, where 1 into 10 power minus 4 molar solution concentration was given at a lambda 500 nanometer, was molar absorptivity extinction coefficient is 5000 liters per mole per centimeter. For the cuvette, the cell length is 1 centimeter was used. So here you remember this formula, absorbance equal to absorptivity into concentration into length of the cuvette, that is length of the cell. A equal to ECl. Now you convert the values into meter, moles. Here this is concentration into meter, and cell you convert into centimeter into meter, and finally you calculate. It's a direct calculation which gives absorption equal to 0.5. So option A was correct. Question number 19. A radioactive substance has half-life period 5760 years. 100 milligram of the sample was reduced to 25 milligram in dash years. You have to calculate here K equal to 0.693 divided by T of. It's a formula. Now you calculate, and T of was given is 5760 years. So you will get the value of K. Now you calculate the value of time. T equal to 2.303 divided by K log R0 by R. Here 2.303 K value already calculated here, and log 100 milligram. This 100 milligram of the substance concentration was reduced to 25 milligram. So what you will get? You will get the time period, that is, it is 11,554 years. So it takes 11,520 years. That is option B is correct. to reduce 100 milligram of the sample to 25 milligram of the sample. Okay. Next question. The number of NMR signal, proton NMR signal excited by room temperature of this complex and at low temperature minus 80 degree respectively. Now you come just observe the structure of the complex, that is the ion Fe2 plus coordinated with the N1 Cp. This is N1, this is N1 Cp pentadienyl ion, and this is N5 Cp. This is N5 Cp here. Now you listen. At room temperature, all the protons in this ring and all the protons in this ring were in the same environment. So you will get proton for this ring is one signal, and the proton for this ring is a second signal. So at room temperature you will get two signals. Okay, at room temperature you will get two signals. At when you lower the temperature, lower the temperature to minus 80 degrees centigrade, you see the proton here in this ring where goes to different environment. So here also this proton goes to different environment. So this comes to one signal, this two proton gives one signal, and this two proton gives one signal. So totally two signal, and this two proton gives one signal, and this two proton gives one signal. So totally this two signal. So totally 2 plus 2 4 signal at minus 80 degrees Celsius. So at room temperature there are two signal, and at lower temperature 4 signal. Answer C is correct. Option C was correct. Next question. Match the following. Question number 21. Match the following. Gas liquid chromatography. It is a partition between gas and liquid. You all know that. And second one, partition chromatography is a partition between immiscible liquids. And third one, affinity chromatography is nothing but a partition between liquid and mobile liquid. That is a liquid and liquid. It is called affinity chromatography. Okay. And supercritical fluid chromatography. These are all higher techniques. It was given by partition between fluid and a bonded surface. So you remember this one. Next question. Hence here option B is correct. Next question is also in match the following, where the catalyst is in different physical phase from the reactants. Here the different catalyst, autocatalyst, negative catalyst, heterogeneous catalyst, homogeneous catalyst were given. Okay. First one, the catalyst is in different physical phase from the reactant is heterogeneous catalyst, because the phases were different. If the phases were same, means it is homogeneous catalyst. Okay. And the second one, the phenomenon, one of the product of the reaction itself acts as a catalyst is autocatalyst. And the third one, phenomenon when a catalyst reduces the rate of the reaction is a negative catalyst. The negative catalyst is one which always reduces the rate of the reaction. So it is a negative catalyst. And the fourth one, when a catalyst is in the same phase means it is homogeneous. So this is homogeneous catalyst. Hence option B is correct. So match the following. And see the paramagnetic nature of the sample can be detected by the paramagnetic nature. You remember the electron, that is the unpaired electron, is mainly calculated using ESR spectroscopy, not IR spectra or Mossbauer spectra or NMR spectra. The unpaired electron, mainly the radical, was the sample was detected using ESR spectra. Next question, 24. Here you see a problem is given. Ferric ion, the weight of the sample was given, was determined by coulometric reduction. Here Fe3 reduces to Fe2 plus, Fe3 plus reduces to Fe2 plus at a platinum cathode. Okay. Calculate the percentage of ferric sulfate. Molecular weight has been given of the sample. This weight has been given required for the reaction. Now listen. For 1 mole of ferric sulfate, the molecular weight was given 399.88. Okay. The reduction of ferric Fe3 plus to Fe2 plus is, we just add this weight 0.8202 plus 103.2775, which is 104.0977. For 1 mole reduction at a platinum cathode, it is 104.0977 divided by molecular weight 399.88. You will get 0.2609. In percentage, you multiply by 100, you will get 26.09%. Hence, option A was correct. Next question. The IUPAC name of the compound is. Now you take this compound. It's isopropyl. Isopropyl moiety is attached to pyridine moiety. Isopropyl is attached to pyridine. Here you see, let's take the 4 molecule, that is structure of these 4 I was written here. You see here option A, option B, option C and option D. The 4 structures. Among this structure, option A was correct. The IUPAC name of this compound is isopropyl 2-cyano. Isopropyl 2-cyano 6-hydroxy. This is 1, 3, 4, 5, 6. 6-hydroxy pyridine 4-carboxylate. Option A was correct. Predominant product of the following reaction is. Here you see this lithium aluminum hydride is a strong reducing agent which reduces this COOET into CH2OH. This reduces into CH2OH. Also reduces this carbonyl group C double bond O into OH. So here you see option A was ruled out, option D was ruled out, and you see in option B and C, here the hydroxyl group was in equatorial position, here the hydroxyl group was in axial position. Now here option B was correct, because due to this bulky group of CH2OH, it OH prefers equatorial position. This is equatorial position. So answer B is correct. Question number 28. The absolute configuration of the compound was given. The chiral center. This is a 2 chiral center. If you calculate, the answer will be yes and yes. This one is yes. You know RS nomenclature. Just calculate the RS nomenclature. You will get this as yes, sinister, and this is also sinister. Option is C. Here I have not calculated. So we'll go to the next question. The correct order of stability of carbanion. Carbanion, various carbanion was given. You see here. In this carbanion, you listen, pH CH2 due to ring current, carbanion was less stable. So pH CH2 was less stable than CH2 COOET, which is less stable than CH2 CO CH3 minus, and which is less stable than CH2 NO2 minus. NO2 minus, the CH2 NO2 minus was more stable because of electronegativity of nitrogen. So answer D was correct. And next question, the reactivity of different multiple bonds in decreasing order of electrophilic addition reaction. If you add an electrophile, if you add an electrophile is an electron deficient compound. If you add an electrophile, this was first one, they are given 4 options, 1, 2, 3 and 4. So what is the priority? They are asking the priority. Now the this electrophile approaches the electron rich center. You remember that one. So we will give the priority, this is 1, first priority, and we will give the second priority to this, and the third priority for electrophile addition is this, and the last fourth priority, because this is due to bridged carbon, here you give fourth priority. Now according to this option, D was correct. They are asking in decreasing order. Hence these are given in increasing order, but they are asking in decreasing order. So you remember this one.